Thank you for inviting me to this event. I'm just live half a mile away in my office. So I'm Hongfang Liu. I been in the domain of healthcare AI for 30 years. How many of you can claim that? So I will just give some background. So I will start with my personal values. This is the kind of driving how I address a healthcare AI problem. So specifically, we know AI has been a powerful ally for, achieving a lot of things, improving patient care. But the healthcare AI is not just about algorithms. It's about how do you make that to be impacting clinicians and the patients alike. So there is a hope component regarding that. In the future, we are thinking AI need to be translated for real-world applications. However, to move that AI to real-world impact, there's still a lot of things need to be done. First is the trust component come with AI. Lastly is the science component with AI. So all those actually, the previous talk gave pretty well regarding the causal AI, all those components, they are a little bit connected here. So my journey in healthcare, I claim I have 30 years. I can show you I have 30 years. This is the grant in 1996 offered, from NIH to Carl Friedman, which is about unlocking data from medical records with text processing. A little bit of history about this project. This whole project actually, if you think about the root, is come from the NYU Linguistic Stream Project in 1966. And that project is funded from DoD. And my PhD advisor was a programmer for that project. And then later, when she became an independent investigator, her PhD, independent research is all about how do we transform the unstructured data in clinical records to structured output. So the task she assigned to me to address is word-sense disambiguation. For those who are in natural language processing field, know pretty well. And so basically, giving a word, which we know they're ambiguous, how do we resolve the ambiguity? So the medley system, as well as the linguistic stream project, they are following the expert-based system paradigm, which is using rules, logic, and also linguistic resources to do the processing. So we know this is the expert-based approach. But to deal with discharge, word-sense disambiguation, there's so many different unseen contexts around. So resolve the ambiguity of it can be quite challenging where the expert system kind of fail in that situation. So my PhD research probably just say, okay, we know statistical NLP become very hard. And can we simply just use a machine learning approach, give a large amount of clinical documents? Back then, we know that if you use a supervised machine learning, creating annotated corpus can be quite expensive. So we are leveraging the knowledge base and try to do a distant supervision using a large amount of data, create a weak supervision data sets, and resolve the ambiguity of it. And we achieved pretty good performance. Back then, I was so proud. I said, I solved the problem of what do you face there, with 90% accurate for some of the words. But unfortunately, the real world is not like that. So when I try to bring this to her, say, can we incorporate this into your medley system? And it's become quite challenging because that system is an expert-based system. And this is a machine learning system. One of the things that still, the comments still stay with me right now is that if a user reports an error in your processing, how can you fix that error? An expert-based system is fixing the error is probably adding additional resource, additional terms, additional rules. But if in machine learning systems, fixing an error is not easy. So these simple things actually shape my understanding of the trust gap in AI, which basically means it's not just about performance of how great your model is. It's about how interpretability, how accountability, and how the responsiveness to the real-world feedback. If you cannot fix that error, when the next time they see the same error occur again, it have a trust issue there. So, this is, in the clinical practice, they are built upon evidence-based medicine. And evidence-based medicine generally come from expert consensus. And the expert AI system, before all those data-driven AI system, in the practice, so they naturally fit that framework. So I joined Mayo Clinic back in 2011. So my first 2 years activity primarily tried to do natural language processing, get information extracted from the clinical text, and to support the expert-based decision support system. And this is show you one example. This specific example is how we automate the SCCP guideline for cervical cancer screening. So the actual, in that expert-based system, we translate the guideline into 41 decision points for managing the surveillance and 13 for routine screening. So you see all those things is that the guideline be translated into an expert-based system. But not all the data for each individual patients are present. So you need to mine the clinical records to find all those yes, no answers there. And this system is complex and it's deterministic, but it's difficult to maintain. But they are perceived to be more trustworthy than the AI system, than the machine learning-based system. So right now we know American faces healthcare challenges. It's an aging population, barrier to access, and rising cost, and also a healthcare system that pays for volume than the value. And meanwhile, we have a lot of data. Everything happens twice. That's something we mentioned. This is something we say for the real-world physical entities through the digital transformation. We have this digital twin representation of the entity here. And then there need to be a feedback loop to the physical entity. This is how I view health data science and AI, is that through those type of data connections, through the research we are doing, we need to return back to the real-world entity. And this is the concept of digital twin healthcare, learning health system. They are all similar type of concepts, which is related to the data can give us insights, how do we act in the real world. And based on the ChatGPT, this is Microsoft Copilot, generate this picture just to say how healthcare in the digital era looks like. So this is basically the patients, the clinicians, the researchers, and systems become increasingly connected through digital technology. We have a tremendous amount of real-world data for us to be working with. And this data, of course, become like a new oil fuel the innovation, and the AI model, then we can leverage that for clinical practice, find cures, translation, all those type of things. But this opportunity comes with a challenge. The first challenge is we call digital overload. In the clinical practice, you probably heard a lot of things about the burnout from the frontier providers, because they are the person need to enter the data into the system. So they play a significant role in that digital transformation. And secondly, come with the trust. AI model, we know a lot of data-driven AI model, lack of the transparency, rigor, all those things relate to that. How do they trust those systems? Lastly, we heard so many things about failed translation due to the lack of science behind it. There's a lack of scientific rigor regarding model to be deployed into clinical practice. One of the things I keep mentioning to people, if real-world data is not a gold standard, our past is not perfect, how do you expect you use that data, generate a prediction which is become gold standard? That's not the way how the world was working. So AI will not fix the healthcare. As an informatician, we know that the challenge go beyond technology. We use technology, we transform healthcare, we create a digital twin for our healthcare systems. But healthcare problems also involve human culture, ethic, and systemic. AI is not a tool, but not a solution. Going forward, so who bears the responsibility for solving those challenges we just said, digital overload, those burnout of the frontline practice, and who bear the responsibility? We know we are digital connected, but this digital connected does not translate to connected, integrated, patient-centered care. The ultimate goal of healthcare delivery is about connected, integrated, patient-centered care. I think it's all of us, right? We complain about healthcare system, but we also have a responsibility to, as data scientists, technology people, to help address some of those. So I think one thing I was pitched to this group is that when you touch upon or think about research questions, think about, are you addressing a real-world problems? And are we engaging stakeholders to ensure solutions are translatable, implementable? So, research is easy, translation is hard. My early career, it's in the institutions without access to clinical data. So I did my PhD with clinical data a lot. Then I spent the first 7 years of my career functioning as a bioinformatician, then clinical informatician on those, because there's no data access. So I joined Mayo Clinic in 2011 for the sole reason of they have so much data. So we're all going to be there, and it's great. So when I arrived there, I actually, with IRB approval, I spent about the first 3 months without ability to get access to the data. And so after that, I say, my research does not really have value because it's not the problem they are facing. The data access problem is a big problem faced there. So I spend, a huge chunk of my time actually try to address the data access issue. So working with the enterprise IT team, talk to institution leaders, CMIO, CIO, say, we need to really rethink about the data platform you guys doing. We need to truly make sure it is the data be used infrastructure. So that's actually become the in 2016, we successfully implement and transform the Mayo data into a real-time data platform where a lot of applications can build on top of it. We only, the effort we put there probably is $10 million investment from the institution. We only generate one paper there. And this is the paper come out of there. And the traditional journal actually don't like those kind of paper. So it's going through 3 rounds of rejection, finally published in BM's Biomedical Informatics Insights. I mean, this is just the story is that, you know, what do you prioritize and what do you align? However, you know, later we actually, you know, found the value of it is that we are the only institution back then with real-time data access. It makes us be able to do things to see how we can use technology to supporting a lot of tasks faced. And one task is basically for cohort identification. And we've been fortunate to get grants, NIH grant to support it. So the time is not wasted, even just one paper for 3 years of effort, but it become, you know, a lot of things we are stay ahead of a lot of people. And we've been funded, fortunate for this grant, being renewed once, and we're still actively working on it. The whole premise of using, embedding, patient similarity, all those things all changed. Our M3 of this grant been changed after 2023 generative AI come, because we were proposing the same thing there, but they have the product out. So, you know, even we didn't get much through, you know, from the building the infrastructure itself, but the impact is huge. That unified data platform, because we transform how data to be managed or used, there's so many publications, so many articles, projects come out of that. So we've been, you know, as a team for 5 years after this in production. We have keywords be funded through using the infrastructure we set up, and we have graduate trainees. Of course, ourselves being also quite successful getting our grants for the methods component related to the infrastructure. We support many projects there with you know, a lot of NIH grants. And we support analytics as a service for the whole institution. So go back to the trust. You know, we know that clinicians trust clinical guidelines because they are transparent, expert-reviewed, and evidence-based. And AI should have the same standards, but how can AI be trusted by clinicians? And our approach actually a little bit different. We build trust through proactively engaging other part. So we're engaging clinicians and do team science collaboration and build evidence so they can see the power of data, power of technology. And so we successfully transform pediatric clinicians to informatician AI expert. They've been, you know, using this. They have ability to translate to clinical practice. And we've been funded as team science research grants also. And leveraging the infrastructure we built through team science collaboration, handheld the team and train them how to use data, how to do AI, and they become an AI person also. And they being able to translate to a clinical decision at the point of care. And this one is a machine learning based approach. Just to say, the trust come to, on the clinical front is their ability to see how this works. The other example is with David Kim from Tufts. because they see we be able to do those kind of work, and we engage them through multi-site collaboration and be able to use real-world data to handle the stroke prevention program. And they are very productive. For both of those team science collaborations, the methods paper probably only 3 or 4 methods paper, but the clinical paper is in a 2030, and all those grants being renewed. And after renewal, we're not part of the team because we're okay with it. We make the other researchers be able to leverage in the technology to advance. So lastly, come to the science component. When AI translate to real world, it's not, they always face this called valley of death. And this is a paper published in 2022 with 2021 as the piece. It's showing that finish model development and get to actually improve surgical care. There's so many things you actually need to do. It's not just by us, it's by everybody. If you are not outreach to the clinical team and think they will just trust what you do, it's not going to work. So mistrust of black box model outputs, no utility prediction ignored, and the time constraints impair clinical use. This is the piece we want to say here. The challenges includes many things. As we said, we digital transform the society, but as a human being, we are not capture all the context there. The digital representation is not a comprehensive, complete picture. So metadata of the data is so critical. The data we have is not the gold standard. And we cannot use the model trained at the Mayo Clinic to be deployed in any of the system institution here due to we have so much difference in the context of the piece. And in 2019, as a team, we published this article, Deep Learning and Alternative Learning Strategy for Retrospective Real-World Data, Clinical Data. And this article, actually, we didn't cite the other article. The other article is by Google DeepMind team and Google team, Jeff. They are talking about using a humongous amount of CDW data and do a predictive model. And they didn't include the benchmark of logistic regression in their model. And as a research team, actually research on it, we were so pissed off. So we didn't cite that paper, but this is the paper to combat that paper. And for those who want to know which paper I'm talking about, I can talk to you offline. So looking ahead, I think AI is a partner in human-centered healthcare, and collaboration and innovate responsibly. We need to translate science into bedside impact. We need to balance hope, trust, and science. So just some advertisement. I'm currently leading the center, which is called Center for Translational AI Excellence Application in Medicine. It took our team a humongous effort to come up with this name because we do want the team to be the keyword in that center name. There's the mission of our center. We do want to revolutionize healthcare AI. We want to advance data science. We want to collaborate. We want to excel. So we want to raise the AI to care. And this is the framework I'm being championing is that team science is the key because only through team science you are knowing or address real world problems. You as in a computer science or me as a biomedical informatician, if we're not in the healthcare environment, we don't know what's the problem they are facing. Trust is very important. Need to be process need to be reproducible, implementable, transparent, explainable. Lastly, need to be rigor. It need to be make sure the data is there to supporting your claim. Just to give an example of evidence-based medicine in the digital era, this is another picture we try to say is that the future of the medicine or future of the clinical research need to be, you cannot ignore real-world data. You need the data science to be an essential part of your team. And as a data scientist, if we also need to think about address the problem, the clinical side facing. So we've been follow that, and we've been actively researching, and our core team is in the center, which is more like CS technology side, but we do a lot of embedded activity with all different disease areas. And these are the last slides, just showing you we are actively working on the teaming perspective, because I think that's the most important piece to build trust and to bring the AI to real-world impact. I still have one slide. This is called the, I'm caution. We know the generative AI, we know NLP, but we are concerned about the future where the domain experts may become the scarcest resource if we do not adopt AI responsibly. This is the bucket theory, for those who are not knowing, is that growth is dictated not by total resource available, but by the scarcest resource. So in the future, AI-powered, empowered society, human expert may be the scarcest resource. That's it. Thank you.
We do have time for some questions.
Oh.
Questions?
Hey, I have a question about the trust, build the trust of AI.
Yeah.
So I see a lot of topics about, how does people trust AI products?
Yeah.
But as you mentioned in previous slides, actually, I'm more concerned about the data.
Yeah.
So a lot of times, the bottleneck is not AI, probably it's the data, right? You spend like 2 months for an AI product.
Yeah.
You spend like maybe 2 years for data access.
Yeah.
So that's why I just want to know, is there any efforts in institution level or across the whole TMC to talk about, how to trust data more, like data quality, data sharing,
So
between different institutes, etc.
yeah, I think there's a line I put is that we needed to build the human connectivity first in the TMC region. So that's the reason we are organizing the TMC AI Summit. We want the researchers and AI and also clinical practice side be working, know each other first. So human connectivity is essential for be able to do that digital connectivity, because we're having the data silo problems in our TMC community. And the other thing I want to comment, still emphasize real world data, there is no good or bad. The data quality investigation can give you a lot of data-driven insights about that care practice. Bad quality has some reason of bad quality. And we needed to study that and feedback to the clinical practice to help improve. So we're in this together.
Thank you. Given that I have a second to ask a question.
Yeah.
You've gone through a lot of suffering in order to get access to that data and to be able to use it in your research. Most of the students, I would say, in the TMC still struggle to have access to data. And would you have anything that you would recommend for them to get started? And how would they approach getting closer to clinical data?
So clinical data, this is all go back to how the, TMC region institution, what's the level of trust they have. But regarding data, there's so much data around, either national level, NIH has through their data sharing management plan, there are a lot of data repositories. So I would just try to say, working with the clinical practice, the clinical research teams, because there are a lot of NIH data sets ready for being analyzed. If you struggle with getting the local data. And for us, we have UT Physician, we have clinical data warehouse. You know, it looks like established collaboration, become our students, have a way to access data. But overall, I think data access should not be a barrier to people who want to use that data to do their research and analysis. Yeah.
That's great. Thank you.
Yeah.
Thank you.
Thank you.